In Delcam for SolidWorks 2012, cutting data can be associated with individual tools in the tool database. These can be set as either material-based settings in the Feeds and Speeds Override tab, or they can be overridden more globally in the tool properties. These new parameters include Z-step increment, step over distance, and ramp angle. We'll get started by clicking on the project folder, and in addition to the usual files, there is this XML file, and this is an exported database. If you want to be able to repeat this demo as it's being done in the video, create a new tool crib and import these tools. It's only 3 tools, and you'll have exactly the tooling you need. I'll drag in the assembly, and this is already a DFS assembly. You can see the Delcam command manager, the feature manager, and of course your stock and your setup. We have 3 features in here, and in reality it's the same feature cut 3 different ways because a different tool is used. Only the tooling is changed from feature to feature, so no other parameters are changed. All the changes you see in the toolpath are going to be driven by these settings we're going to make in the exercise. I'll give you a little more information about the tooling. I'll go to the SolidWorks feature manager, and inside the design binder there is a Word document. Okay, the Word document simply has this very simple chart which gives us a little more information about these 3 tools. All 3 tools have been defined with a 10 mm cutter length. However, they cannot actually cut that deep. The 10-degree insert can only cut 2 mm deep because of its geometry. This 45-degree insert can cut 6.5, and the 90-degree insert can cut the full 10. So let's take a look at that in action. I'll go to my first feature, which is the 90-degree insert, and first of all we'll take a look at the tool. So I'll go to the operation and select tool. I'll double click on the tool to go to the properties, and the first thing I want to show you is on the overrides tab. There are 3 new settings here: depth, step over, and ramp angle. If I set these settings, they'll become more global settings for this tool. No matter what material I use, it'll use these settings. Of course, this can all be overridden at the operation level, but there's nothing set here. So I'll go to the Feed and Speed tab, and where we normally have feed and speed overrides, we've added more input. I'll open up the properties, and you can see the usual feed and speed numbers, but below that are some new parameters: a depth of cut and a step over for this material, aluminum. Even though the tool can cut 10 mm deep, it's recommended that in aluminum we only cut 8 mm deep, and our step over is 25 mm. I'll click OK and get out of these windows, and we'll look at the toolpath. This feature is 15 mm deep. I'll run the toolpath, and as you might expect, we get 2 cuts because our depth of cut is 8 mm. Now, Delcam for SolidWorks will take uneven step overs and sort of distribute them evenly. So since this is 15 mm deep, instead of getting an 8 mm depth of cut and then a 7 mm depth of cut, we're going to get these equally distributed into 2 cuts of 7.5 mm. An enhancement that's coming very soon in DFS is the ability to clear that equal cut setting so that you can have true 8 mm cuts, and then the last cut will get whatever's remaining. And there you see our step over of 25 mm. So this is exactly the behavior we expected based on those overrides. Okay, let's take a look at the next feature. This is the 45 medium cutter. I'll go to the op list and look at the tool. And on the overrides page, you see a more global setting. So our depth has been set to 3 mm, our step over has been set to 15 mm, and the ramp angle is just whatever the default value is for the file. I'll go to the Feed and Speed tab, and there are no custom settings here based on material. So no matter what material we use, we'll get these numbers, of course, unless we override them. Okay? And we'll check out this toolpath. Okay, obviously more steps, and again, I didn't change anything but the tool, and a narrower step over. If I go again to the properties by double clicking the operation, it will show us that even 3mm depth of cut. Of course, this was able to work out evenly because it's a 15mm deep feature. And there's our 15mm width of cut. So this worked exactly as expected. Now we'll go to the final feature, the 10mm insert. Of course, it had a maximum depth of cut of 2mm. Back to the op list, back to the tool. Again, no global overrides for this tool. And on the feed and speed tab, we actually have two. We have one for aluminum and one for P20 tool steel. And also the feeds and speeds are different. So 500 RPM as opposed to 796. If we look at these properties, we can see that for aluminum we have a 1.5mm depth of cut across the board and a 15mm step over. And if we look at the tool steel, here we have a 1mm depth of cut and a 15mm step over. Again, this is an aluminum part, so let's take a look at the tool path. Again, now even more step downs. Fortunately, one more time, our overall depth does divide equally by our step overs, so I expect to see exactly 1.5mm in that 15mm step over, the 796 RPM that we saw in the feed and speed overrides. Let's change the material of this file and see if that behaves as expected. I'll go to my managers, select stock material, drop this down to the P20 tool steel, OK, and close. And let's run another toolpath. I'm expecting to see a 1mm step down and a 500 RPM. Alright, let's double click. 1mm, 15mm step over, and 500 RPM. So there are a few different ways you can control the feed and speed for a tool. We can go more globally by just obeying whatever's in the feed and speed manager. We can override on a material basis by selecting specific settings on a material by material basis, or we can set more global settings that work regardless of the material.